In this video, we're going to look at MUS Lesson 23, and this is on corresponding parts of triangles. So let's look at these triangles that we have right here. This is triangle ABC and then triangle DEF. If I said that these two triangles are congruent, how do they relate to, how should I read them as congruent? Should I say that triangle ABC is congruent to DEF? I should not. I should put the corresponding parts, the parts that are congruent, I need to list in the same order. So when I look at triangle DEF, maybe it's congruent, but it would be a lot better if I flipped it over and saw it the same direction that it was, that triangle ABC was. So here I flipped it over, and yes, the F is now upside down, but I can see now that A, B, and C are going to relate to D, F, E, not D, E, F. So when I write that these triangles are congruent, I'm going to write that triangle ABC is congruent to triangle DFE because I'm writing them in the same order. Angle B then corresponds to angle F. So angle B must be congruent to angle F because B is in the middle and F is in the middle when I list it. And then angle A corresponds to angle D right here. And angle C corresponds to angle E. Now remember, I had to flip this over, but in your book, when they are printed on there, you can't flip them over, but in your head, you may have to rotate it. I think it's easier to figure out exactly how they relate and list them in that order, and then it's easier to do all the parts. So I can look, and now that I've listed the triangle in the correct order, starting with the same angle and going to the ones that are congruent, then it's really easy for me to say, without even the picture, you know, A must be congruent to D, and B must be congruent to F, and C must be congruent to E. And so then if I said, okay, so line segment BC, what's that congruent to? Well, BC was the last two listed, so if I keep going in the same order, it must be FE. Now we're going to look at our triangle and make sure, but BC is this line right here, and so that would match to this line over here, so these line segments are the corresponding parts of these triangles. So here's another example, two triangles below. Look at the ways to write how the triangles correspond and then how the angles and sides correspond. So I started over here and I said triangle ABC corresponds to triangle DEF. But I could start and go down across the bottom. So that was this one right here. I could start right here and say that triangle ACB corresponds to DFE. So if I start across the bottom on this one, then this one that's facing the same direction, I'm going to start across the bottom because I can see that AC is the same size as DF. So those are the corresponding parts of the triangle. If I started over here and said CBA, then on this one, I'd have to start over here on that smaller angle and say FED. I can also relate all the sides, side AB to DE, side BC to EF, side AC to DF, and then I can relate all of the angles. 2 relates to 5, 1 corresponds to 4, and 3 corresponds to 6. And then if they were congruent triangles, I could list all those parts as congruent as well. So if triangle GHI, so I'm going to say triangle GHI corresponds to triangle KJI as the picture shows. Well, K is down here, KJI. So in my head, I'm trying to rotate it so that I can line them up to the corresponding sides together. What are the corresponding angles and sides? So we're going to have to list all the angles as they correspond. So I kind of see this one looks about 90 degrees. This one looks about 90 degrees. So again, if I take this triangle, I'm going to like rotate it on top of this one. That's how they line up. I can also, again, use just the order that I have right here. So angle G, which I'm going to say is HGI, HGI. And look, I used HGI. So I'm going to have to start in the middle, and I'm going to say JKI, JKI. That would be this one, JKI. And yes, that one looks like it will correspond to that one. So how about angle I? How about if I use HIG? So angle HIG, which is this one right here, that's going to correspond to, well, this one is the same size. And thinking about our proofs, that's a vertical angle. And so the vertical angles are congruent. How am I going to name this angle I? Well, if I kind of look, I did HI and then I went back to the beginning on my triangle. So I'm going to say JI and go back to K. So angle JIK. And again, that's JIK. So I go across this straight line, and that's how I listed it over here, HIG. All right, the last angle would be the one that looks like it's 90 degrees. Can't say that it is, because on proofs, we can't just say it's 90 degrees because it looks like it. We have to prove it. And here we have no angle measures, so we don't know for sure. This I might call GHI. And when I list it that way, it's right in the same order that I listed my triangle. So angle GHI corresponds to angle, listing in the same order, KJI. So again, that was the one I marked, KJI, I marked that one, and then GHI, I marked that one. In the same way, we would say that this side corresponds to this side, and HI corresponds to JI, and GI corresponds to KI. So those would be the corresponding sides. Now we're going to look at some relationships between an exterior angle and the interior angle of this triangle. So I'm going to just be calculating what these angles are. So I see that this is a straight line right here, which means that it adds up to 180. So I'm going to say 180 degrees minus the 65 that's already over here gives me 115 degrees. So I know that angle 3 must be 115 degrees. If 3 is known, what are angles 1 and 2 added together? Well, let's look about that. I know that 1 and 2 are inside the triangle, and with this 65 degrees, they all have to add up to 180. So the measure of angle 1 plus the measure of angle 2 plus 65 equals 180 degrees. If I use a little bit of algebra and I subtract this 65 on both sides, then I have that 115 is equal to the measure of angle 1 plus the measure of angle 2. So that was because of the inside of the triangle equaling 180. Then these two left have to add up to 115. And look, adding these two up gives me 115, and adding this one up gives me 115. Does that work every time? So this would be kind of the transitive property. If the measure of angle 3 is equal to 115, and the measure of angles 1 plus the measure of angle 2 is equal to 115, this one may be substitution property, but again, that substitution and transitive property are kind of interchangeable. So if we substitute in what 115 was equal, that's the measure of angle 3 in right here, then I could say the measure of angle 3. Or if I want to say A equals B and B equals C, so C and A must also be equal because we're kind of substituting in that B, then we call it the transitive property. So we use that transitive property to make this connection, that these interior angles are equal to this exterior angle. We call this an exterior angle. We also can have exterior angles over here and off of this side, but these two angles are remote interior to this exterior angle here. And they're the remote because they're the furthest away. They're not the interior angle that adds up to 180. They're the other two. So these remote, these far away interior angles, they're remote to this exterior angle here. So angles 1 and 2 are remote interior angles from angle 3. So let's see if it works over here. 62 and 118, does that make sense? So is 180, this straight line, minus 62, that is 118, so that works. And then if I know 62 and I have 180 inside this entire triangle, I could say that 44 plus 74 must be equal to 180 minus the 62 that we already know. And 180 minus 62 right up here, we just said was 118. So these remote interior angles to this exterior angle are equal. 44 plus 74 equals 118. So we can conclude that the measure of the exterior angle, this one over here, is equal to the sum of the remote interior angles. So if we have a triangle like this, how can we find the measure of angle A? Well, we can say that we know that these two remote interior angles have to add up to this exterior. So 123 is equal to A plus 70. We never even have to mess with B. We know that these two will add up to this exterior angle. And then we can just subtract 70 on both sides. And we get that angle A is equal to 53 degrees. So we didn't have to step through B to find what A was. We could use our property that we just learned to figure out what it was. So that's really all there is to lesson 23. It's pretty straightforward.